Welcome Tech Brothers Now. In this video, we are going to take a look at what is the difference between data flow and copy activity in Azure Synapse Pipelines. Now, what is copy activity? It is used to move data from source to the destination with the optional basic transformations such as column mapping and filtering. So there is not much other transformations available in the copy activity, and I have shown you guys how to use the copy activity in different pipelines in previous videos. If you guys want to read more or learn more about copy activity, you can always go to my website TechBrothersIT.com and then look for the Data Factory tutorial step by step. Here I have the all transformations and activities covered. So you can see right there copy activity here, and you have many demos on those copy activity, and the different scenarios are covered in this one. Now also you can go to the Tech Brothers IT YouTube channel and search for the what you call the playlist, and in the playlist you will find such as Azure Data Factory playlist, and this has almost 200 videos. You can click on any of them and then you will be able to see copy activity, data flow, and other many scenarios that I have covered. Now let's go back here, and we understand the copy activity is a activity that can be used to do the very basic moving data from source to destination. So it's really good, it's fast as well. It is deployed for performance and cost. So when you need to copy data from your ADLS Gen 2, maybe blob storage, or from your Azure SQL DB to other destinations, you can use copy activity, commonly used for ETL and ELT ingestion pipelines. So this is very basic information about copy activity, and I have shown you the demo as well. Here is the example or use case, copy CSV file from ADLS Gen 2 to the dedicated SQL pool table. We have done that demo as well. So you have seen how to use copy activity. And what is DataFlow? A code-free transformation engine built on Spark. And this is you don't have to write any code, you don't have to write any notebook. You will be using graphical transformations, and under the hood it will translate your graphical transformation to the Spark code, and then it will run on that Spark code. Allows complex operations such as joins, aggregation, derived column, pivot, unpivot, condition split, etc. So if you need these type of transformation on your data, you need to use the data flow. You cannot do this in the copy activity. Use the integration runtime to spin up a Spark cluster under the hood. So when we run this data flow, it has to run a Spark cluster. So there is a different size of those Spark clusters, and you can choose small, medium, and large size when you need to run. So if you have or you are loading a large size data, performing a lot of operations, you might want to choose the right one that works for you. You can always test and see which one works better for you. We will see in the demo as well. Now cleanse and transform a large data set before saving to the curated zone or SQL table. So data flow is very important, as I said, that you can do a lot of things such as joins, aggregation, derived columns, and etc. And then finally you want to write to some staging area, and maybe finally ingest into the dedicated SQL pool. There is no direct to dedicated SQL pool connector available in the sink that you can write the data to the dedicated pool. So you have to write into some staging area, maybe as a CSV or Parquet files, and then you can use the copy activity to load the data. And we have done a copy activity how to load data from CSV to the dedicated SQL pool. So when to use simple data movement for copy activity works great, but if you are doing simple data move, you want to do data flow, that's overkill. That's not really good. So use copy activity. It is a simple data movement. Format conversions, both of them can be work great when you need to perform some formatting with the conversion data types and all that. Complex transformations such as join and pivot, so copy activity does not allow that, and data flow does allow that. cost sensitive workload. So in this case, you will be with copy activity, you will be paying less money, and with the data flow it is higher cost because every time it has to use the Spark cluster. So it has to spin up a Spark cluster and then use for your running the data flow transformations. Now small data sets, yes, it works great with both of them. So even you have a data set, small or large, you will be fine with the copy activity and data flow as well. Depends upon the which transformation you need to use. Even the data set is small, but it needs join, pivoting and filtering and all those derived column, then you will be using data flow. Reusable transformation logic. So no, then in the data flow we have those transformations and we can reuse them. Now here's the billing differences. Copy activity billed based on the data volume moved. So let's say you want to run the copy activity and it is a 0.25 DIU per hour, then you are going to see that like how many DIUs you use. If you have more data, then the more DIUs will be used and it will take more time, so you will be paying accordingly. Very cost effective for large scale ingestions and it works pretty fast with the large size files and everything. Data flow build based on the vCore per hour, so Spark cluster. So when we create a Spark cluster, then you are going to see the billing, startup latency and higher compute cost. So every time you run your data flow, it's going to take like 2 to 3 minutes to spin up the Spark cluster and then run it. So there is a higher cost for the compute nodes in the data flow. So prefer copy activity unless advanced transformation is required. We have seen that if we need to join, pivot and all those, then we will use data flow. Otherwise our best is the copy activity. Now example hands-on or data flow or conceptual. Imagine you have a file landing in sales.csv in ADLS Gen 2 with the raw sales data. You want to filter only countries equal to USA and drive a new column, total price is equal to quantity multiply unit price, write to this new curated folder and create as a Parquet file. So in this case data flow makes sense to use it. In this case steps in data flow will be source will be this one, filter will be this one, and derived columns will be this one, and then sync will be ADLS Gen 2 Parquet. The type of logic is not possible in copy activity alone. So this type of whatever we are doing right here, all that is not possible in going to be in the copy activity. You have to use a data flow. Use copy activity for fast, simple movement of structured data. Use data flow when transformation logic become too complex to manage in a SQL or mapping. And monitor cost implications of data flows, batch similar workloads. Reuse transformation using data flow templates. So you can create the templates and then you reuse them as well. So this is the difference between copy and data flow. I'm going to go ahead and show you actually the billing. So here is the billing part. You can see that I open for Data Factory and pretty much the billing is same for Data Factory and Synapse because they use the same copy activity and data flows. And you can see right here data movement activity. So that's for copy activity 0.25 DIU per hour. And then you can see that if you are using self-hosted it is less, but in that case you will be using your own computer to install self-hosted IR. And then other like you have pipeline activities, so they're 0.005 per hour, external pipeline activities, so 0.00025 per hour. So you can see that this is the main component what we are talking about, the 0.25 DIU per hour. Mostly with the files when you're loading you are using 2 DIUs or maybe 4 DIUs, and this can go to 64 DIUs if you have large file and it's going to load it quickly, so it has to use more power, and that's where you will be using. Now with the data flow, and you can see right there the journal purpose and 0.274 per vCore per hour. So when you define your cluster, Spark cluster, you have to tell like how many vCores you are using and all that. So this is the billing for per vCore per hour, and then you can kind of compare which one is the best for you. As I said that you have to make a decision if you have to use the data flow because you cannot use joins and unpivot, pivot and drive column in the copy activity, then you have to pay this cost. Let's go back and now we perform our demo here. So we are going to go ahead and create our new pipeline. Let's go to the integrate tab here and then our create a new pipeline. So once we are done here, we can give a name to our pipeline. I'm going to call this one PL data flow and then say join. Now in this case, what I want to do, if I will go to my container here and I have some files sitting in this blob storage. So this is a blob storage also attached to my workspace, and it has Synapse container, then it has an input container, it has customer CSV, and then I have a order CSV. I want to read these two files and then join them on the customer ID. So if I will take a look on this, there is a customer ID is the same. Also I can go to right here in the data, go to linked here and use the same Synapse container here, and then go to the input container. So if you see right there in the input container, I have customer, so I can right here click and say customer ID, first name, last name. So that's a preview of my data. In the orders CSV, I can also preview it, and I can see that order ID, customer ID, and order date. Customer ID is the mutual column in both of these two files. So I'm going to join them and then create a new file, maybe in the output container, output demo container. I call that is a output CSV or whatever. So here is our pipeline now, and we can go ahead and go to the move and transformation and drag a data flow. Once we drag the data flow, we can name this one. I'm going to call this one data flow 2 or whatever name you want to give. And once you give the name to data flow 2, go to settings here and select actually you can double click here, and now we can say new, and this is our data flow 2, and we are going to build that. Now what's going to happen, you can add the source here, so click right here, and then it's added the source. Now in the source, we have to add the data set from where the file will be read. So I'm going to go to new here and then go to the ADLS Gen 2, and I know that my file is a CSV file, so I select that and then I go to the link service. I can call this one DS customer, and customer for DF data flow, and then I have to create the link service. I can use the link service if I have already, or I can create new. I'm going to create new so you can see what steps I take. I'm going to use system assign identity here, and then I have to provide the subscription in which my blob storage account is. So here is my storage account, and that's what it is, and I'm going to test it, and then test is successful. I'm going to call this one link service ls, and then say Tech Brothers storage account. Okay, let's create that, and now our link service is created, and now we can navigate to the file. So let's go right there, and we are going to go to the folders and files. So Synapse container, in the Synapse container, I know that my file is sitting under the input folder, and now I'm going to select the customers.csv. It has the first row as a header, that's fine, and take a schema from the connection. Okay, fine, and now you're all good here. Now next I have to add another source. In this case that will be our second file. That's our order file. So create a new data set here, and then I will select ADLS Gen 2 CSV file again, and then I can use this called DS order DF. Okay, so that's my data set. I can use the same link service I just created, and because it's pointing to the same storage, so I don't have to worry. We can use the same instead of creating the new one. And here I go to container, then I go to the input folder, and then I'm going to select the order CSV file. Looks like it's taken a lot of time, and what I'm going to do, I'm going to cancel this out, come back again and try to load it again. So go to root folder and Synapse container, and in the Synapse container input folder here, and then we have order table, order.csv. So select that, and yes, it has also the first row as a header. So import schema leave from connection store, that's fine, hit OK, and now we have two sources ready. So we have one source that has 3 columns, and this one also have 3 columns, and then we need to join them. If you click on this one, you can always preview data right here, and this is gonna refresh and you will be able to see the data from your customer.csv file. Okay, here is our customer data, and then I can go to the orders and also do the same thing, and if I refresh, it's going to show me the order data. Okay, so we can see that there are some customer IDs and we can join on them and get that. Now hit click on this plus sign, and then you're going to see all the transformations available to you. You can scroll down and up and choose the one you like. Here is the join one that we want to use. I can leave this join as is, or I can call it join customer and then order. So if you want to give some nice name, you can always give some nice name. And name contain invalid characters. Okay, fine. So I think it's only accept underscores, so let's give that underscores, and now see if it works better. Okay, still maybe it is error, so you don't have that just leave no space and everything. Now it is fine. Now this is the join we have to perform, and in the join it give you full outer join, inner join, left join, right join, custom join, and all that cross joins. So you can select the one. By default inner join is fine, and I want to join on a column such as so here is my source. So this is my customer ID coming from my first source, and then it is my second. So second is going to be my customer ID as well. So I'm going to give this so I have to join this with this one, right? So this is okay, sorry, I didn't select the right stream. So here's my first stream, that's source 1, and I have to select the right stream here, so source 2. Now they are made the connection as well, so you can see that they are connected. Source 1 and source 2 are connected with the join now. Then we should be able to see the columns here, and here is my second column coming from customer ID from the order table. Now join looks great, and next we need to add the sync. So here I'm gonna go ahead and type sync, or go all the way down here and add sync. If you go to sync here, and then you have to tell what is the name of the data set. I'm gonna go ahead and say new, and then where I would like to create the data set, I could simply go to the ADLS Gen 2 and hit continue. Want to create the CSV file, hit next, and I'm gonna call this one DS customer order. And here's the link service. We can use the same link service as it is belong to the, we are trying to write to the same storage but different folder. So use the same link service, and here I'm going to browse to the different folder. It's taken forever here for loading that container, so I'm going to cancel this out and then retry, and let's go to root folder here, and then I hope it came back Synapse container, and then in the Synapse container again I'm going for the output demo. So this is the folder I would like to create the file, and I don't want to select subfolder. I'm gonna just create on the main folder, and I'm gonna call this dataflow.csv file. That's the name of my file. And yes, create the first header, and then from import schema leave this actually to none, and we will select that by ourselves. Now go to mapping here, and instead of auto mapping, go unselect this, and then these are the columns it's going to generate. But I'm not interested in customer ID twice because I'm doing inner join, and I know that customer ID is going to be the same. So source 1 at the rate of customer ID is this one customer ID. I'm going to just delete. If I want to rename some columns, I can do that too, you know. So first name, let's say if I want to be like, hey, I want to call this F name, I want to call this L name, and then order ID is fine, and customer ID I want to say C capital and O capital here. So I can use all those different things, whatever I want to do here. Now this looks great, and this is going to create our file. I'm going to go back to sync one more time, and I'm going to go to the settings here, and here in the settings I'm going to take a look on the file name option. If I will run this my data flow right like this, it's going to create a file with say part 00001.csv, because it works in parallel and in Spark, and I want to create actually a single file, and that's what output to a single file. That's what I'm going to choose. And here it is asking me what is the name of the file you want to give. So let's give the same name what we have given here in the sync data set. So if you go to the data set here, and this was the CSV. So actually I don't have to give this name here when I'm selecting single file. So I'm going to go back here in the data flow, and here is my settings, and in the setting you can single file. So I'm going to give name here. Okay, set single file partition, because now it will be writing to the dataflow.csv file. So that's great, and everything looks fine, and we don't need to make other changes. In this case, I have set this data flow debug ready, so it means it has created this cluster for me, and that's why I am able to execute this to the pipeline. So I go back to the, not in the data flow, I'm gonna go back to the, if I go to debug setting, you can see right there it shows me some row limits, and show me some how many records are it's going to read and all that. So you can settle if you want to change to something. It's auto resolve runtime, so that's a compute. If you need to pass some special parameters, you can pass the parameter. I don't have those parameters, so I'm fine. Here this you have to enable DataFlow debug to execute this pipeline which has DataFlow. If you don't, it's going to not run your DataFlow. So I have enabled this one, and when you enable it, take almost 2-3 minutes it enables it, but it runs for 1 hour if you don't disable by yourself. So you will be paying the money for that Spark cluster for almost 1 hour. So I will once I run it, I will disable and try to enable and show you what are the options. So let's go ahead and to the pipeline. Here we can publish all the changes if you want, but if you don't want to publish, that's fine. And I'm not going to publish here. I'm going to just debug. And same thing, this is a pipeline, you know, that you can add a trigger, you can schedule, and you can do all those kind of things that you want to do it later for later. And we have done this already. So in you want to run this pipeline on schedule that has your data flow, you can always schedule and everything. So this is in progress right now. You can take a look on the input. It tells you like, hey, your data flow name is there too, and it is a 8 cores. If you see right there, a core count is using Spark cluster, that's 8 cores. So per vCore we are paying 0.27 per dollars per vCore. So it is a multiply 8. That's how much I am paying. If you remember that, if I go right here, so 0.274 per vCore, and the cluster we are running right now is the 8 vCore. So you have to multiply, and that's how much you will be paying. Now if you go back here, you are going to see some more information. Here is your source. You can see, okay, total 3 columns, and how much time it took, what are the total partition and everything, and file system duration. So and then here same information, and here is your join, and then here is your destination. So you can select all that and take a look into details. Now you can go back here. Now in this one it's still running. Let me go back to my pipelines here to the integration, and here's my pipeline. It's in progress right now. So let it complete first, and then I will show you more details. Okay, our data flow is completed, and here's our final output. You can click right there again, and it tells you all those details. You have already taken a look. You can always go to monitor here. In the monitor you have these pipelines, and in the pipelines you can see that pipeline you just ran, and you have to go under the debug, because we did not trigger that pipeline. We run in a debug mode. So you can see right here, and you can also click here, and it will take you back to the edit of that pipeline. Now let's go back to our container here, and remember that we have to go to the Synapse container and then go to the output demo, and here is our dataflow.csv file created by the dataflow. If I will be in the Synapse and I want to take a look on that file, I can go to the data here, go to linked here, and then find the linked service, and here is my Synapse container, and then output demo is right here as well. And I can always right click here and preview the data. It should have a first name, last name, order ID, customer ID, and then order date, and it showed me only where the data matches for those customer IDs with the customer file and order file. Okay, great. So this is how you will be using a data flow in case you have to perform those different transformations. Now let's go back here, and I was telling you like, hey, guess what? So if you are in the data flow, you have to enable this data flow debug. I'm going to go ahead and disable, so we don't get charge anymore. And now it is disabled. So if I want to rerun this data flow again, what I have to do, I have to enable. So once I tell like I want to enable, it tells me, hey, guess what, you want to be you use what, auto resolve integration time, yes, and then it tells me the compute size is smaller, and then it asks me the region, so it is all going to auto resolve maybe East US or whatever the best for me it is going to use. Then see debug time to live, so it's going to be 1 hour. So if you will leave this on, it's going to be charge you for 1 hour. I will suggest always turn it off when you are done with the debugging. Now let's go back here in the pipeline, and here let me see if I can show you some more options here. So here, if you go to the data flow and then go to journal, then you go to the settings here, and then compute size is there as well. So you can select the compute size, and here is small, medium, large, custom. So if I use custom here, it tells you now, hey, basic journal purpose or memory optimized, depending upon your load that you want to load the data. So you have a large of files, so maybe standard general purpose is going to work just fine, but in case you have memory optimized transformations or which need to like sorting or something like that, you will be probably need a memory optimizer, but not with a smaller size. Then you have core. Here you have 4 plus 4 cores, so for your compute nodes and for your drivers, and then you have same right here, 4 plus 4. So you have different configuration available for your first Spark cluster. You have also 16 total compute node and 64 compute nodes and 16 driver cores. So if you do more, and then I don't think so there is a more, this is the max you can have it, I think. So you can always select the Spark cluster that you would like to create to run your data flow, and once you save it and this data flow pipeline will be executed, what's going to happen is going to automatically, so let's say in this case, if I'll say 4 plus 4, now I have this one, I save this, and I'm going to close this actually, this tab, because this is creating problem, and I'm going to publish it now. So okay, data flow pipeline has at least one activity. So which one is that? So this data flow is not needed, so I'm going to publish the ones I have. Now our once I publish it, and you see that my Spark cluster is I have saved the compute here, and I want to tell like 4 plus 4, so it's total 8 vCores. So once this pipeline is deployed with this configuration, and what's going to happen if I go to my pipelines here, and this is my pipeline, right? So we close all this, and guess what we are going to do, we are just going to cancel this out. And now if I go ahead and execute this pipeline, and or we can trigger from here, or maybe we can schedule to trigger. So if I want to trigger now, what's going to happen now, let's trigger, and then now it's running this pipeline, view pipeline run. So if you see this one, what's going to happen is going to take like 2 or 3 minutes. First is going to create that Spark cluster, and then after creating the Spark cluster, then the data flow will run. So if we go back here, so right here, see it's in 8 cores general purpose, and now it's going to start that Spark cluster and then run this data flow for us. So see right here, it says queued, and on top of that it says that number of transformation total 4, yes, and data flow status acquiring compute. So right now it is going to create that Spark cluster under the hood that it need to run these transformations. So you can see now the status has changed, and now it says data flow status running. And now it says run successfully. Now this has completed, and if I refresh here, let me refresh here, now it should be completed successfully. So you saw that it took almost cluster startup time 2 minutes 45 seconds, and then it ran these transformations. One thing I want to add to it, I don't know if I did, maybe I forgot. If you are using DataFlow, the sync will not be the dedicated SQL pool, so you have to create the CSV or Parquet files, and then later on you can use the copy activity to load them. So if we go back here and refresh, now we should see that it's a overwritten file later on during the day that just got created. So I hope you learned something out of it. I thank you very much for watching. Please subscribe my channel, and I will see you guys in the next video.